Well, good afternoon. Hello again. Most of you I saw yesterday. So I'm talking about this improvement of customer value estimation by predicting conversion from, I am Allan Dieguez. I'm a data scientist at Creditas. So a little more about me. I'm working with machine learning since 2006. That's 11 years now. And I've worked with computer vision, and mostly with computer vision and text mining. And recently with driver behavior prediction, dynamic pricing, and customer value. And I have mostly worked in startups, only startups. Well, about the company, Creditas. We are a fintech startup, one of the top 3 most funded. We raised about 90 million reais. And our main product is secured loans with collateral. If you have a house or a car, you can get a loan, refinancing it for as low as 1.15% a month. Okay. Well, and the problem we have at hand is the conversion funnel is predicting the customer value in the conversion funnel. The conversion funnel is something we use very much in Creditas. It's all the knowledge we have about the customer, just in a picture. So we can know how many steps we have until the person who asks a loan gets its money. So the first level is the customer acquisition, where we go around and spend our budget in Facebook and marketing and everything else. And we get some random people who wants money. Then we do processing. That is, we want to fill all the forms and gather all documents that we can analyze to get to the next level, that is credit analysis, in which we see if the person has a probability of not paying us, and then we discard these people. But if you're a good payer, you're going to get your credit. Then it's underwriting, that is financial and legal stuff that comes just before the customer gets his loan. So all the knowledge we had until we did this analysis was based on our operations team. The operations team talks to the customer and gets its document, enters on Google Maps and see if the house he wants to refinance exists, if it's in a rich area, if it's in a poor area. And all of this is very expensive. So what we want is to optimize this work by predicting the probability of the customer to get to the next level of the funnel. So we have all this data about the customer that we are increasingly putting into the system. The databases of the core system is mostly what we consult to get the data. We have the images of the documents, normal documents proving the houses of the customer, proving the ownership of the car, identity and this stuff. We have user location when he fills the forms, home address, which is important to know his financial situation and even the collateral, if his house is in a good place or a bad place. We use domain knowledge. We have lots of domain knowledge. We have a gigantic team of operations. Chat and email, we process text. And also the device type the user uses to access our system and get all his info into our system. So customer value. This is a simple figure showing what we want to do. We have these random people in a random place in our customer funnel, in our conversion funnel. And we want to segment these customers as how much he will provide the company at the end of the process, and what is the effort we will have to convert this customer into a paid person. So we use this info to segment our clients to give a more accurate treatment to them, a more personalized treatment, and also to optimize how we are going to get these customers if they come in thousands of people. We cannot increase the size of our operations teams in every crisis the country has. So we start by brainstorming solutions. We had some ideas of how we're going to do this. We just sketched it. We didn't implement these to test. We tried regression to try to predict mostly what's the profit the client will give us. We tried clustering and similarity and see if the customer is easily compared to another customers who got the loan or another customer who didn't got the loan for any problem. But we stuck with classification, which is a very direct approach to get to. So as a classification problem, we have all this information about our customer, and we want to predict the short-term conversion. That is, if the customer in this level has a good probability of getting to the next level, and also the long-term conversion. We want to know if he's going to get the money he asks for. If he converts easily on a previous level of the funnel, and he don't get the money he asks for, we have to measure the effort we have to put on this. We can also know if we put a junior operation person or a more senior to help the person get more chance of taking this loan. So with all this information, we sketched the solution. With the data we had, we use the intended loan, how much money this person wants. We get some personal info too, the age, the gender, if it has a family, a dog, a house, how many houses. We dive into the financial info too, the family income, and well, most of all the access info to the system, the devices, which I talked about earlier, and most importantly, the collateral info. Like if you have a car, you want to refinance it, we have to know the car model, the car year. You will not want to refinance a Beetle from '74. That's not a good car to refinance. You'll get at most, what, 1,000 reais? I don't know. So after we get our features done, we select the architecture for the classifier we want to train. I just love to ensemble classifiers with a lot of different classifiers and get them together to work through a bigger performance. And we have these two targets we want to see. We mostly get it get it from our system. In the short-term conversion is if the lead converted to the next level or not, if he was discarded. And the long-term is if he was approved for the loan or not. We are not using if he got paid, because that's most legal stuff, and sometimes legal gets weird and takes too much time, and sometimes the customer just doesn't want the money anymore. But if he was approved, it's a good sign. He should go through the funnel. And also feature engineering. We have most of the data isn't numerical, it's text, it's some signals we measure. So there are 3 samples of feature engineering we do. I won't dive much into it because we had a very good presentation yesterday about feature engineering. And then the training. Well, I know this isn't new for most of you, but I like this figure. It shows a good practice of splitting the data set into train and test, so we can measure if the solution is overfitting or not. And also doing a grid search, exploring hyperparameters. Most people like to explore more architecture, but if you have more knowledge about one architecture specifically, you should dive into the hyperparameter to get the best parameter sets to train your data. Mostly, it tells more about your domain than the model itself. So from the grid search, we get the best model, and we test it on the test data. For the grid search, I like to use cross-validation to choose the best model. This is the fairest mode of training because you don't have to split your trained data anymore. You sometimes don't have that much of data to expand. So, after all of this, we have to do a soft deploying. It's just not wise to put your model into production without measuring how it affects your problem. So mostly we cluster our clients into several groups. For example, clients who have apartments and clients who have houses. And we test evenly the new algorithm and the old solution, even if it was zero solution, random, choosing at random. This way we can test if the seasonality isn't affecting our measures. If you test this on the winter, the people can ask for more money because they want to buy a house because their house isn't hot enough. So we have seasonal and local info that you can measure just by switching the algorithm. And also we have it spread evenly with our operations team because you can have a very good operation guy who can take anyone from the start of the funnel to the end of the funnel. And you can have this junior guy who just entered and he doesn't know how to handle. We don't want to bias our measuring by just choosing wrongly who gets who. Everyone gets a piece of everyone. Everyone gets a customer from all the groups and all the algorithms. And this is under development. We are planning to put the model on continuous learning. And we are measuring which type of continuous learning is better for us. We are testing now if just ensemble new models into the pool of models is a good idea or not, or just continue training the models. If you use a neural network, this is perfectly doable. But if you use a random forest, for example, it's not a good idea. You have to retrain from scratch. Or kill the old model and train a new model. So, I think I'm ahead of my time. Yeah, so, thank you for hiring.
Thank you, Allan, for your presentation. You actually finished a little bit early, so we have plenty of time for questions.
Okay.
Okay, we have one here.
Hi. Hi. On one of your previous slides, you said you collect the browser history from the user.
Yeah.
You mean the history of access to a specific user inside your website, or do you have any way to collect the entire browser history from someone?
No, unfortunately not. Just cookies is what everyone else gets. I don't have the exact history. I cannot reconstruct the way the person gets to the site. But with analytics, we can know from where the customer came. Okay.
Yep, many more questions? We have here in the back.
Hi. Martin, over here. Here.
Yeah. Sorry.
Do you not consider to use some microeconomic indexes into your model because some scenarios of the credit default, the government goes wide with inflation or some kind of other indexes, and did you not consider to put this in your Steiner model to reinforce the model?
Yeah, we considered that, but we didn't put in this first version. We are measuring those some variables we get from the locality of the collateral, the house. If we know how the economics is affecting the neighborhood, we can infer some things. But yeah, the next step would be to use more macroeconomic data, just to leverage our perception, not to bias it with like the crisis, for example. Okay.
We have one.
Okay.
Here.
Hi. You talked about ensembles, right?
Yeah.
I wanted to ask you how you go. You get each data scientist to develop a model and then you assemble everything, or is just you developing a bunch of models and then you stack everything? How do you do it?
Yeah, I wish I have much data scientists to put a model to each one. I'm half of the team. That's why we are hiring. Please apply. Okay. So no, unfortunately, I go and train all my models. Sometimes I trick Barbara into training some for me too, and we just assemble them into one model that averages the outputs of the output. Okay.
We have one last question here.
No, you can ask more questions. I want to ask one question. Sorry.
Sure.
It's my dual role here. Sometimes it gets confusing. So sometimes these models, when you have talking about, for example, credit history of people, they can be socially unjust because you might have a part of the population, for example, who might live traditionally in a certain neighborhood, which is associated with poverty, either sometimes via racial lines or whatever, or culturally. How do you take this into consideration when you're building your models, or do you just take a completely financial black and white approach?
Well, we're not processing this information as we should. This type of information. I hope that putting more data that's not just financially attached to the loan, we can average more what we know about the customer. But yeah, we should have these areas. There are some techniques we can use to eliminate most of the bias that we have, such as, I don't know, the hand feature engineering. You can put the family income and divide it by the average income of the neighborhood. So if you have a poor area, you can have just a percentual of the income of this particular person to the rest of the people who lives in the same area. And in a rich area, you can have the same. It's mostly, we're trying some things. We deployed the first model for this just 2 months ago. So yeah, thank you for the idea.
All right, guys. I know there are more people wanting to ask questions, but for the interest of time, I'm terribly sorry, but I have to actually, Ruben just told me that we will probably go ahead a little bit more to enjoy, because otherwise I have to throw everyone out of the building. So okay. Please, you can talk with Allan later. Let's thank him again for his presentation.